All right, guys, welcome back to the second lesson of calculus. Today is about some important parent functions. This is going to be important when we graph. Really, today's lesson is really going to be, if you notice, there's 21 pages, but it's mainly going to be me just flipping through some parent functions. You'll need to pause the video if there are any that you're unfamiliar with to get the information about them. If there's anything super pertinent that I think you need to know about one of them, I'll tell you, but for the most part, it's going to be me just flipping through, showing you what each of these parent functions look like. And huge thank you to Michael Poor over at Eastside. He gave me a fantastic overview of these parent functions, which is why I've kind of just put them on here, and I'm just going to kind of let them speak for themselves. So before we do that, just want to talk about a few aspects of functions. So we know that domains, set of possible input values. Range is a set of all possible output values. From algebra, you should have talked about even and odd functions. If not, basically what an even function is if you input f of negative x, you get back out f of x, then it's an even function. And even functions have reflectional symmetry across the y-axis. For odd functions, f of negative x is equal to negative f of x. And graphically, they have rotational symmetry around the origin. And then last, another thing that we're going to see in some of these parent functions is asymptotes. Asymptotes are values that the function approaches as either the input or output values of the function approach infinity. So you're going to see infinite asymptotes in some of these parent functions. So I'm just going to flip through some of these parent functions. I'm going to stay on the page for a few seconds. If there's something that I think you need to know about the notation, I'll tell you. But really what you guys are going to do is you're going to go through this video, and if there's any that you're unfamiliar with, just pause the video, jot the information down, draw yourself a picture, and then move on to the next one. So this is the basic linear graph, y equals x. Again, if you need any of these, pause the video. I'm just going to start rolling through them, and I'll leave them on the screen for a couple seconds before I move to the next one. One important thing to note with this one, e to the x, as with any exponential function, the y-intercept is at 0, 1, because anything raised to the 0 power gives you 1. And if we notice, this is the first one we have that has an asymptote at y equals 0, because as we look over here, as x goes towards negative infinity, this value is going to approach 0. The value of the function will approach 0. Over here, when we're looking at the domain and range, this notation here is interval notation. This U means union or. So what this means is the domain of this function is negative infinity to 0 non-inclusive. It's non-inclusive because there are parentheses. A bracket would mean inclusive, and then 0 to infinity. What that means basically, because these are non-inclusive, the domain can be any number except for 0, and then same thing with the range. It can output anything except for 0. This is a graph that you've seen before, but you may not have seen it broken up into a piecewise function. This is the graph of the absolute value of x. Basically, it's the graph of y equals negative x if x is less than 0, and just the graph of y equals x if x is greater than or equal to 0. And just like I was talking about with inclusive and non-inclusive, as you see here, 0 has a bracket with it on the range, meaning that this interval is inclusive, so 0 is included in the range. One important thing to note here, square root of x is the same thing as x to the 1/2 power. If you did not deal with rational exponents, basically x to the 1/2 is square root of x to the 1/3 is the cube root of x to the 1/17 is the 17th root of x. If you had something such as x to the 3/4, that would mean take the 4th root of x and then raise it to the 3rd power. Or conversely, raise it to the 3rd power and then take the 4th root of it. One important thing to note here with ln of x, I know it looks like the graph just starts right here, That is actually not true because as you can tell from the asymptote, x equals 0. What actually happens here is this graph hugs the y-axis and goes down, and there's an asymptote right here at x equals 0. That's important to note, and the reason that it looks like that is this is what your calculator does when you graph this function. So it looks like it just stops here because your calculator cannot do input values that are that close together and make a line right here, but there is actually an infinite, nearly straight line that goes right down here. So we just saw the graph of sine of x. This is the graph of cosine of x. Don't get these two confused. One way that you can tell one from the other is to look at the y-intercept. So for sine of x, the y-intercept is 0 because sine of 0 is 0. And for cosine, the y-intercept is 1 because cosine of 0 is 1. And right here, it doesn't have the asymptotes listed, but the asymptotes actually everywhere that there is a domain issue, that is an asymptote. So these are all, it has an infinite number of vertical asymptotes. So this function is a least integer function. So what this little bracket right here without the top side means is take whatever number x is and use whichever integer is the closest to x but less than x. So if you notice right here, there's this little horizontal line between 0 and 1 because for every single number that's between 0 and 1, the closest integer that is less than that integer is 0. Same thing like right here between 1 and 2. There's a little horizontal line of y equals 1 because let's take like 1.99 for example. 1.99, the closest integer that is less than 1.99 is 1. So this is called the least integer function. And right here, this says y is an element of, this z means integers. So this says the y value, the output is an element of the integers. This is a function that you may come across when we're talking about limits. So this is the graph of absolute value of x divided by x. Basically what this is saying here is if x is positive, you get 1. If x is negative, you get -1. And if x is 0, this does not exist because you can't divide by 0. So this is like I was talking about before with fractional exponent, rational exponents. X to the 2/3, would that mean cube root of x and then square it? Or you can square x and then take the cube root of it. And then this is just another form of the equation of a circle that you know. So this graphs the top half, and then the other portion would graph the bottom half. So that's it for today's video. Today was just about some important parent function graphs. We are gonna go through what we can do with these in class, but basically anytime that we need to graph something, we need to be able to identify which parent function it came from and can tell us some characteristics of the graph. I hope that you took some notes, are ready with questions, and I hope you have a great day.